So today we are going to form indirect neighborship first of all, because yesterday in BGP we were just going through indirect neighborship with using their loopbacks, and we saw that even like for EBGP by default TTL value was 1, and in between R1 and R2, I mean, we were trying to form EBGP pairing with using their loopback addresses in between R1 and R2, but still they were not initializing that neighborship. However, neighbor was just one hop away, right? So only TTL value 1 was required, but still BGP was not initiating your neighborship due to connected check rule, directly connected check rule, right? So we disabled that rule, and then we saw that okay, BGP formed neighborship between R1 and R2. Even we didn't configure, we didn't change its TTL value. But this time, I mean today we are going to form neighborship in for BGP in between R1 and R5. Let's say we want to configure EBGP pairing or IBGP pairing in between R1 and R5. I mean to say that we want to configure indirect neighborship in between two indirectly connected devices, right? So do one thing, let's configure EIGRP between all these routers. Let's configure EIGRP in between these 5 routers, so that all 5 routers will exchange their loopback addresses with each other. So let's start it from R1 itself. Say router EIGRP 100 not summary network 1.1.1 and then network 12.1.1, and that's it. Do show IP EIGRP interface. You see that EIGRP has been enabled on these 2 interfaces of R1. Now let's move on R2. Router EIGRP 100 not summary network 000 will be enough here, right? So do show history and then just copy and paste on all other devices as well, like on R3 as well as on R4, and then we can move on R5, and on R5 we can set up EIGRP 100 not summary network 45.1.5 and then network 5.5.5. So I hope you people try EIGRP interface, right? So now you see that you must receive the R1's loopback over here, right? So you can ping from the loopback of R5 to the loopback of R1, like you can try ping 1.1.1 source is loopback 1. So you can see that they are communicating with each other successfully. Now you do one thing, trace route 1.1.1 from here, and source is what, loopback 1. So see, it is just 4 hop away from here. Your neighbor is 4 hop away from here. Fine, we have come to know that okay, my neighbor is just 4 hop away from here. Then let's go back on, let's move back again on R1, and on R1 you see, first of all I will show you that how can you configure IBGP neighborship, right? And we will also see that for IBGP neighborship there will not be any problem for BGP, right? It can form IBGP pairing without any problem, because by default for IBGP outgoing TTL value is configured as 255. So router BGP 100, and then after say neighbor 5.5.5 source is, sorry, remote AS is what, 100 itself, then neighbor 5.5.5 update source is loopback 1, just to modify your source. Now if you want to activate your neighbors, then you have to disable default address family. You have to disable default address family, and then after you will require to create address family for IPv4 by yourself, I mean to say statically, manually, right? So all these things are there. Now you do one thing, move back again on R5 and say router BGP, here I will be running 100, then say 1.1.1, remote AS is what, 100 itself, and then 1.1.1 update source must be loopback 1. You will see that now they will form IBGP pairing with each other without any problem. There will not be any kind of problem over here. It can form IBGP neighborship without any problem, because by default for IBGP its outgoing TTL is configured as 255. So IP BGP summary. See, neighborship is still in active state, but finally it have came up now, you see. Understood? So in this way you can see that indirect neighborship will come up in case of IBGP neighbor, and you can also see show IP BGP neighbor that outgoing default outgoing TTL is what, 255, as I hope that you have seen it before as well. So outgoing TTL is what by default, 255. So there will not be any problem in case of IBGP neighborship, and I hope that I have already told you that how to advertise prefixes in BGP. There are two things. I mean, okay, I think I have discussed only network command till now, right? Fine. I'll be discussing it with you, don't worry. Now, let's remove this BGP from here, no router BGP 100 from here, and also move back again on R1. Say no router BGP 100. Fine. BGP has been removed from from R1 as well as R5 now. And once again, let's configure BGP 100, and this time in between R1 and R5, I'll configure eBGP neighborship. So neighbor 5.5.5 remote AS is what? Let's say 500. Neighbor 5.5.5 in source, it must take its loopback address, and then move back again on R5 and say router BGP is what? 500. Neighbor 1.1.1 remote AS is 100. Neighbor 1.1.1 update source is loopback 1. Now you see one thing, move back again on R1, show IP BGP summary. The neighborship is still in ideal because your outgoing TTL is by default 1, and if your outgoing TTL is configured as 1, which is by default, in that case it has to check this. It has to go through connected. Directly connected check rule. It has to go through directly connected check rule. So of course, its outgoing TTL is by default 1, and this time it will check whether 555 is directly connected to R1 or not. So if it is not, then definitely BGP is not going to initiate your TCP session. Hello. So this time what can we do? We can again disable that directly connected check, right? So I will say router BGP 100 and neighbor 5.5.5 disable connected check, and then I'll move back again on R5 as well. Over here also I will say disable connected check. Fine, but still neighborship will not come up, because still outgoing TTL is what? 1, whereas from R1 R5 is 4 hop away. So what but now at least it will try to form neighborship. So IP BGP summary, you see it has moved into active state, but still neighborship will not come up due to outgoing TTL 1. So remember, in BGP by default outgoing TTL is configured as 1, so that is why here now it is not possible to send all these SYN messages, especially SYN messages, because it will send SYN message to form TCP session. So its own SYN message will never be delivered onto R5, and R5 will also try to send SYN message. In that case, the SYN message generated by R5 will never be delivered on R1. Even you can check it out. So it does not mean that disable connected check will work everywhere. No, if your neighbor is more than 1 hop away, then disable connected check cannot work. See, it sends SYN message, but what is it sending back? ICMP message TTL exceeded. Neighbor is telling back to sender that okay, your TTL was exceeded. Fine. Hello. Now you do one thing, change its TTL value. So to change TTL value, first of all you should trace route your neighbor so that you can confirm that how many hops are there in between you and your neighbor. So of course here how many hops are there? 4. So here I will say router BGP 100 neighbor is 5.5.5 and eBGP multi-hop. Remember, this multi-hop command is only for eBGP neighbor, not for iBGP neighbor, because there is no command like iBGP multi-hop. There is no command like iBGP multi-hop. So there is command like eBGP multi-hop only. So this time neighbor 5.5.5 eBGP multi-hop is what? 4. And in same manner I will move back again on R5. From R5 also try to trace route your neighbor, which is 1.1.1. So of course you can have asymmetric routing as well. That is why it will be good for you to trace route your neighbors from both ends, right? Because might be that you are having asymmetric routing somewhere in the network. So of course the number of hops can be different. So this time again it is 4. So I will say router BGP 500 and neighbor 1.1.1.1 and then tell me is 4. Move back again on R1. You see neighborship how came up now. Show IP BGP summary. Take it out. Show IP BGP neighbor. It is eBGP neighbor external link and then outgoing TTL that we configured, it was 4. Now fine, everything is okay. Let's move back again on R5. Try to understand now. I was having a loop back, let's say 10, IP address 50.50 or 50.1. I can advertise it into BGP. Fine. Now it must be available, see, in the BGP table, local BGP table of R5 itself, and then it must give it to R1. See, it is there. But remember that this route will not be present in the routing table of R2, R3 as well as R4, because BGP is not running over there. So here if you see to IP route, so you can find 50s prefix via BGP. But if you move on R2, of course, if you wanna see 50s prefix, you will not see, because we didn't advertise that 50s prefix into EICRP. We advertised that prefix into BGP only, and for R5 its neighbor was only and only R1. Now you can say, sir, BGP updates are coming through R2, R3 and R4, then why are not, why those routers are not having these see, updates were unicast, and those were updates. Inside update you were carrying these prefixes information. Try to understand. Update packet itself were having these prefixes information. Update packets were carrying these prefixes information, and those updates packets were those updates packets were unicast. So basically R3, R2, R3 and R4, these routers will be transit routers for those packets. So they will simply perform lookup, because we transmitted packet from R5 to R1 and it was unicast and destination IP was 1.1.1. R4 performed a lookup that how can I reach 1111. It came to know that okay, I can reach it via R3. It gave, it transferred it to R3. Then R3 performed same functionality. Then R3 came to know that I have to send it via R2. Then R3 also performed same task, and of course R2 came to know that okay, this packet has to be transferred to R1. That's it. So basically for R2, R3 and R4, these three routers were transit routers for those, for the packets of BGP, for all packets of BGP, because all packets of BGP will always be unicasted, and if you are not a end host, if you are not a end router, then it is not possible for you to open that packet. That what kind of information is containing, is contained by this packet. Router will never open if it is not a end host. So this time see, this prefix is available in the BGP table of R1, but still from R1 you cannot ping with 50.1.1.1, because it will give that packet to R2. R2 doesn't know anything about the 50s prefix, so it will simply drop your packet. So there is a black hole. This is called black hole. It is something like, for an example, you are having an ISP, and on both ends behind customers you are having private networks. So private networks are available in the background, behind R1 as well as R5, but it's not available on R2, R3 and R4. Fine. So forget about it. I just wanted to show you that okay, if you advertise anything, it will be available on its neighbor but not on all devices. Fine. Now there can be a problem. There can be a security problem or security risk in BGP itself. Like, for an example, someone behind R5, someone have spoofed IP address of R5 as well as IP address of R1. Someone have spoofed IP address of R5 as well as R1. An attacker have came to know that BGP peering is in between R1 and R5, and that attacker is residing somewhere behind R5. Like behind R5 you are having R6, R7, and then ISP. On ISP your attacker is there, right? Now attacker have came to know that okay, BGP peering is configured in between R1 and R5, and now attacker have that information as well, that what is the IP address of R1 and what is the IP address, what is an IP address of R5. Now attacker created an update packet. In that update packet, attacker added so many prefixes, bogus prefixes, so bogus routes. And in the source of the update packet, attacker mentioned 5.5.5. In the destination, attacker mentioned 1.1.1 and placed onto network. So that packet will come to finally R5, because it, of course, R6 will be having that information that how to reach 1111, right? So R6 will hand over it to the R5, R5 will hand over it to the R4, R3, R2, and finally it will reach R1. R1 will receive that BGP update packet and it will think that okay, it is coming from R5. It is coming from R5 and it will accept it and also will give an acknowledgement back to R5 and install bogus routes, unknown routes inside its own BGP table. Are you getting my point or not? In same manner, in BGP as well, virtual link could be configured. That's why in OSPF also for virtual link now in latest iOS we are having TTL security. You understand what I mean to say? So this time, see, attacker can perform this task, right? Attacker can attack on your network and can inject some bogus routes into the BGP table of your router, into the routing table of your router. That's the problem. That's the big problem now. How to solve this problem now? Because with using authentication you cannot solve this problem. With using authentication, because still it will keep neighborship with R5. An attacker is somewhere behind R5. Attacker do not have neighborship with you. Attacker simply have the information, simply have this information that what is the source IP address and what is the destination IP address. I mean, what is the IP address of R1 and what is the IP address of R5. Now attacker can create any packet, update packet of BGP. In source it can define 5555, destination, in destination can define 1111. I hope that you people have understood it. That's the problem. To solve this problem in BGP we are also having TTL security. In place of BGP multi-hop command we can also implement TTL security. Let me show you. Let's move back again on R1 and router BGP 100 as I configured here. BGP multi-hop in same manner I will try to configure 5.5, I mean for this neighbor, that TTL security. And before going to configure TTL security you have to calculate that your neighbor is how many hop away from here. So it was 4 hop away from here. So because my neighbor was just 4 hop away from here, so I'll say neighbor 5.5.5 TTL security and hops, and then how many hops are there? So it was 4. So what is it saying? That you can have only one command, either BGP multi-hop or TTL security, right? So remove previous command and now configure TTL security. So remember that at one time you can configure only one command, either BGP multi-hop or TTL security. In same manner, now move back again on R5 and router BGP it was 500 and remove the previous command. And then say neighbor 1.1.1 and it will be using TTL security hops. Fine. There is a rule in BGP that if you configure TTL security, then by default outgoing TTL will become 255. If you configure TTL security in BGP, then by default its TTL value would be configured as 255 outgoing TTL. Remember, I mean try to understand, if you configure TTL security in BGP, then by default its outgoing TTL will be configured as 255. Are you getting my point or not? When you configure TTL security in BGP, by default your outgoing TTL value will be 255. Fine. Now it has become 255. Then what is the uses of this command? Is for with using this command, like we are saying neighbor 555 TTL security hops 4. It means we are telling to this router that my neighbor is just 4 hop away. My neighbor is just 4 hop away, and it knows that if it has configured TTL security, if it has configured TTL security, then outgoing TTL will be by default 255. So I have configured here that my neighbor is just 4 hops away from here. It means 255 minus 4, it will be 251. It means I must receive packet from my neighbor with TTL value 251 or higher, not less than 251. Wow. See, when you configure your TTL security in BGP, by default outgoing TTL value will become 255. Fine, that's cool. And now you have configured this command as well, neighbor 545 TTL security hops 4. With using this command, you are specifying that your neighbor is just 4 hop away. And if your neighbor is just 4 hop away, and because neighbor will send all BGP packets with TTL value 255, so over here they must come with TTL value 251 or higher than that, or like 252, 253, but it cannot be less than 251. And see, if any packet is coming from the same neighbor, if any packet is coming with TTL value lower than 251, it means it is coming from an attacker, because attacker cannot change TTL value. If the packet is originated from attacker, it means TTL value will definitely get changed, and this thing cannot be handled by an attacker. So whenever attacker will send any packet, let's say with TTL value 255 from R6 or from R7, right? So it will reach R1, but it will not come with the TTL value 251 or higher than that. It will come with TTL value, lower than 251. So if any packet comes with TTL value lower than 251, it will simply discard that. Even you can check it over here, show IP BGP neighbor, check it out. See, what is this? Outgoing by default have become 255 and minimum has been configured as 251 now. So if any packet is coming with TTL value, minimum TTL value is 251. If any packet is coming with TTL value lower than 251, it will simply have you understood or not? So whenever attacker, see, if attacker is residing somewhere in between R1 and R5, then you can't do anything. You can't prevent your network with using any method with using anything over here. But if you are, and of course within your network there will not be any attacker. And one more thing, this TTL security is not for IBGP neighbor. It is only for eBGP neighbor, because IBGP neighbors will always be in same AS, and of course IBGP neighbor means it is fully secure. We can assume that IBGP neighbor will be secure because IBGP neighbor is residing in our own AS. That is why this command, this TTL security is not there for IBGP neighbor, because IBGP neighbor will always be reside in your own AS, and of course if your neighbor is in your own AS, it means it is fully secure. So this TTL security works only for eBGP neighbor. So I hope that you people have understood the concept of this eBGP, this TTL security. Have you understood it or not?
Yes, sir.
For sure. Try to memorize it. Keep quiet. So see, I have taught you uses of eBGP multi-hop, TTL security, and now I am going to teach you that how to secure your neighborship. How to configure authentication in BGP. To configure authentication in BGP, it's very simple. Like for an example, this time it is having neighborship. So IP BGP summary, you see, it is having neighborship with 555. So go to route BGP mode. It was 100, and then say neighbor 5.5.5, and then simple password. Password is what? Cisco at 123. That's it. That's password in BGP. By default it will be using MD5. So in this way you can you can configure authentication for BGP. Tell me, any problem? Remember, authentication must be configured on both ends. But the problem is in this iOS, Even after configuring, authentication neighborship is not going down, and this is the bug of this iOS only. This iOS in GNS. That's it. It's not gonna to break this neighborship. Even you can wait for 3 minutes. However, it will break neighborship after 3 minutes. But actually, before breaking up your neighborship, before tearing down your BGP peering, it will start to show you TCP notification. MD5 mismatch. It's not it, but it is not showing you anything over here. It means that it is not gonna to break. It is not gonna to tear down its BGP peering. So that's the problem of this iOS. But this is the way in which you can configure password in BGP, or you can say authentication in BGP, and by default it will be using MD5 algorithm. Understood? Fine. Let's start this BGP once again. Say no router BGP 100 here. Say no router EIGRP 100 as well. No router EIGRP 100. No router EIGRP 100. No router EIGRP 100. No router EIGRP 100. Fine. What will I do now? I'll configure AS100 on R1, and on all other devices here I'll configure on all these 4 devices. Fine. Or okay, let's do one thing first of all. Before going to configure IBGP, let's configure 200 over here, and then on R3 I'll configure AS300. So all of them will be having eBGP neighborship. Here it will be having eBGP. Then here in between R1 and R3 it will be having eBGP. Fine. So let's start it from R1 now. And router BGP 100, neighbor is 12.1.2, remote AS is what? 200, neighbor 12, sorry, that's fine, that's enough, right? And in same manner, let's move on R2 now. Router BGP 200, neighbor 12.1.1, and remote AS will be 100, neighbor 23.1.3, remote AS will be fine. Neighborship must come up in between all these routers now. First of all, let's move on R1, show IPBGP summary. Fine, it have came up. On R2 as well, show IPBGP summary. With R3 still neighborship have not came up. Let's do wait. Yeah, it have came up now, right? And then on R3 also it must have neighborship with R2. Now what will I do? I will advertise something from R1 actually in BGP. And to advertise in BGP anything, actually I used network command till now, right? I can also say, I mean, apart from network command, you can also use redistribute connected keyword. So you can also advertise prefixes in BGP with using redistribute connected command as well. So it will advertise everything, I mean all those prefixes which are directly connected to this router into BGP now. But this time, because you are redistributing your connected prefixes, so their origin code will go as question mark. Previously, I mean, if you advertise anything into BGP with using network command, then by default its origin code will be I. So you see now, do show IP BGP. Check it out. See, question mark. And there is nothing AS path. See, one more thing. If next hop is 000, it means it is advertised by you only. If next hop address is configured as 000, it means it is advertised, I mean this prefix is advertised by your router only. You can move on R2 now. You can check its BGP table, it must be there, I mean both of them must be there. See, Now you can see for 12's network there is a keyword which is R. R means RIP failure. RIP failure. And the meaning by RIP failure, the meaning by small r over here is that it is receiving this prefix 12.1.0 via BGP, but also it is having this prefix available inside its own routing table through another source. So this 12's network was already directly connected to R2. This 12's network was already directly connected to R2. That is why it is not installing this 12's network in its routing table, which is learned through BGP. It is installing in its own routing table which is directly connected. As you can see here, 12's network is directly connected. And then after you can move on R3, and on R3 also show IP, you can run this command and you can see that next hop is changed. See, I didn't configure anything. I simply said that whenever your router will give an update to your BGP neighbor, then it will always update its next hop address. So this time R2 is giving an update to R3, but after modifying, after updating its next hop address, because for R2, R3 is working as an BGP neighbor. See, for R2, R3 is working as an BGP neighbor. You can see here. So R2 is giving an update to R3, but after modifying its next hop address. So now you can move on R3 and you can check its BGP table in same manner. You can see show IP route. See, it has installed these prefixes inside its own routing table as well. So I hope that you people have understood that how can we advertise prefixes into BGP. One method was, we used network command, and here on R3 also I can advertise. See, router BGP is 300, say network 3.3.3.3 mask is what, /32. So now you will see show IP BGP. Check it out. This 33, but this time origin code is what? I. So remember, see, in the last of the line, whatever is mentioned, whether I or question mark, it means it is what? Origin code by default, right? So it will be origin code in, whatever is specified in the end of the line, whether it is question mark or I or E, it means it is what? Origin code. So here we have seen that what was advertised into BGP after redistributing is having its origin code as question mark, whereas whatever we advertise into BGP with using network command is having origin code as I. Check it out. So in BGP, whatever you will advertise with using network command will be containing origin code as I, whereas if you are redistributing anything into the BGP, then by default its origin code will be question mark. Fine.
Doctor, when it showed her failure, it showed that R only because the other source was present.
RIP failure will be shown inside BGP table in only that condition when your router is also receiving the same prefix via another source as well, and that is getting installed inside its routing table actually.
Another source is present.
Exactly. Like on R2, we received this prefix inside its BGP table, as you can see, but it is showing you RIP failure because this 12's network is directly connected to R2 as well in its routing table. It is not installing this prefix 12.1.0/24 via 12.1.1 in its routing table. It is not installing this prefix inside its own routing table. That is why here it is showing URIP failure. Any problem? Tell me. So I hope that you have understood this concept here of BGP, that in which conditions its origin code will be question mark, in which conditions its origin code will be I. Apart from it, now I'm also going to tell you something over here. Like we are on R1, right? I said here redistribute connect. Do you remember? Redistribute connected, and then after now I'm saying auto summary. See, I used redistribute connected, and then after I have enabled auto summary. So you will see whatever will be advertised now by BGP, by BGP, it will be auto summarized. See, check its own BGP table itself first of all. But remember, this auto summary will be effective. Auto summary will be effective in case of when you are saying redistribute connected only. And if you are advertising anything with using network command and mask value, like we did it on R3, check it out. Is not it? do show IP BGP, it is installing it on /32 itself, and then I moved back into BGP router mode, and then again I said auto summary do show IP BGP. Is there any effect onto it? So auto summary will not work for that command in which you have advertised your prefix with using mask keyword. This auto summary keyword can work. Auto summary can work in BGP in that case only when you are redistributing your connected prefixes. Tell me. Now if you want to see, if you want to see effect of your auto summarization even after without using redistribution as well, then you have to do one thing. Remove this network command and mask keyword from here. Say network 3.0.0.0 class full. However, here it is not mandatory for you guys to specify its mask as well, because it is now what? Class full. So this time, because auto summary is enabled, so this time BGP can advertise this classful network. You know why? Because it is having at least one prefix which belongs to this classful network in its in its routing table. So this time you can see do show IP BGP that it will advertise this 3.0.0.0. So if you are using mask keyword even after enabling auto summarization, then it will not work actually. So remember, auto summary keyword will not work for those statements which you have given into BGP with using mask keyword. After enabling auto summarization, you can do what? You can advertise your class full network. Even you are having classless network available inside your routing table. Like here I was having only 3.3.3.3 on /32 itself. You see, do show IP route. Let me show you. But still I can advertise 3.0.0.0 from here because auto summarization is enabled. Once I will do one thing, no auto summary. Now check its BGP table. 3.0.0 will not be there. However, I'm still saying that 3.0.0.0, but this time it will not advertise it, because if you have said no auto summary, then exact whatever you advertise into the BGP table with using network command must available in its own routing table. Exactly same, right? So say check it out, do show IP BGP, still it is not there. But if you say 3.3.3.3 mask is 245, and now you see do show IP BGP, check it out. So these are the very small things in BGP that you must remember. Like as I said, redistribute connected, right? And then I said auto summary. So it summarized all of them. It summarized all of them, all prefixes that you redistributed from connected routes into BGP. Tell me, have you people understood this concept or not? So these are really small things but really important, right? So you must remember all these rules of BGP now and onwards. Fine. So this was all about that how can we advertise prefixes, what is the meaning by auto summarization, and also I have taught you that in case of eBGP it will always modify, it will always update its next hop address before transmitting outgoing updates. Whenever BGP will give an update to its neighbor, before giving those updates to its neighbor, it has to update its next hop address. But this time what will I do? I'll be using same AS200 on all these devices now. And here it will become now IBGP. Here also it will be now IBGP. Do one thing. Once again remove everything. Removed, and according to this diagram we will do some configuration over here, right? Fine. So router BGP, remote AS is what? I'm advertising its on prefix now. Mask is what? Only this one, right? Now let's move on to say remote AS will be fine. And also will remain because this time yes. Move on R3. Move on R4 as well. Any problem? I'm not going to configure BGP on R5 right now, right? I'll do it later on, but right now I'm not configuring BGP on R5. So I have configured BGP on R1, R2, R3 and R4. R1 is in AS 100, whereas R2, R3, R4, all of them are in AS 200. Fine. I hope that you have seen that I advertise this 1111 on R1. See, it will give this prefix to now R2. No problem. Then it will advertise it towards R3. And whereas R3 is what? IBGP neighbor for R2. Will it change its next hop address now? So it has proved that whenever a router will advertise anything towards IBGP neighbor, it will never update its next hop address. And due to this reason only, now it is not best. See, on R3, is it best? You know why? Because its next hop address is not reachable from R3. Because you can check its routing table, is there any 12 network? Now to solve this problem, you have two solutions. Either do one thing, configure IP route 12.1.0, 255.255.0 and 23.1. Now it is best. But if you remove this static default route, once again it will become, it will not be best now. Check it out. Just wait. See, now it is not, because its next hop address is not reachable. So how can we solve this problem now? Because R2 is working as edge router. Yes. So do one thing, move back again on R2, and on R2 you can configure this command, neighbor 23.1. Once you will configure this command on R2, see on R2 I configured it only for IBGP neighbor R3, not for R1. R2 was receiving this prefix coming from EBGP neighbor and giving it to IBGP neighbor R3. But this time after configuring this command 23.1.3 next hop self, you see that on R3 what will happen? Next hop has been updated. You understand? Next hop has been updated. Now R3 must, because it is best for R3, so it must advertise it towards R4. But will it really advertise towards R4 now? No, due to IBGP rule. Because if you receive anything, any update from one of the IBGP neighbor, then you will never advertise it towards another IBGP neighbor. It means that on R4 you cannot find this. Any problem? So how can we solve this problem now? By using route reflector. So what can we do? We can define this R3 as a route reflector server, and we can define this R2 as a client. Even we can also configure this R4 as a client as well. It's not mandatory, but you can, right? As you know that route reflector can exchange routes in between, can reflect routes in between client and non-client, client, but it is not possible for route reflector to exchange to reflect routes to reflect prefixes in between two different non-clients. So move on R3 now. And on R3, as you know very well, that we are running AS200, and then you wanted to configure 3.1.2 as a route reflector client, and in same manner you can also configure 34.1.4 as a route reflector client. Fine. So this time you must see this prefix available on R4, but again for R4 it is not best, because might be next hop is not reachable. 23.1.2, is it reachable from R4? See, check its routing table now. So of course, if we configure next hop self command on R3, then its effect should be on R4. So move on R3 and then say 34.1.4 next hop self. Once you will configure this command over here, you see there is no effect. Remember, next hop self command can work only on edge router when you are receiving prefixes coming from eBGP neighbor and you are advertising them towards iBGP neighbor. So remember, this next hop self command will work only for edge routers. That's why it was having effect on R2, but this time it is not having an effect. Effect on R3, because R3 is not working as a edge router. So I hope that you people have understood that way to use next hop self keyword. Then apart from this, because still it's not best for R4. So now you have two solutions: either configure a static route or whatever you want to do, but 23's network must be reachable from R4. If this 23's network is reachable from R4, then definitely R4 can define this path, this route as a best path. We have disabled this IBGP rule now. Route reflector. Yes, we are having configuration as well, but right now I'm not going to discuss either route reflector. Even we will also learn these route reflectors on large scale as well as configuration. So configuration is another way to break this rule of IBGP apart from route reflector, but we will be discussing them later on. So now you can see that due to next hop issue, this path is not best path for R4, and if it is not best for R4, how will it be possible for R4 to give it to R5? Of course, it cannot advertise this prefix to any other neighbor now, because it is not best for itself. So how can we modify its next hop address? It's possible with using route map. Dinesh, with using route map, here we can modify its next hop address. Try to understand. With using route map, we can modify next hop address, and route map can be applied anywhere. So it's not that route map can be applied. With using route map, we can modify next hop address only on edge router or on core router. There's nothing like that, because route map can be applied anywhere in the network, and with using route map you can update next hop address anywhere in the network. Even you can also, to inject a problem in BGP, you can also configure any unknown address as next hop address, so that BGP will start to create so many problems for you. Cisco can do it during T-shoot. So this time, first of all, see, for R4 it is incoming update. It's coming from its neighbor R3. Hello, R4 is receiving this prefix coming from as you can see, show IP BGP 1.1.1.1. You can also see its detailed information. So what is it? This is next hop. See, this is prefix. This is the next hop to reach this prefix, which is not accessible from here, and it is given by this neighbor 34.1.3, and this is the router ID of the neighbor. See, from means this is your neighbor address IP address, and this is the neighbor's router ID from where we are receiving this prefix actually. So this time R4 was receiving it from 3333. So what is the IP address of 333? 34.1.3, and what is the router ID of R3? It's 33333, highest loopback, is not it? And then that's fine, it is inaccessible. So make it accessible now. Show IP BGP. If I modify its next hop address and if I configure its next hop address as 34.1.3, if I configure its next hop address as 34.1.3 in place of 23.1.2, will not it work? Of course it must work. It must install that prefix into its own routing table from BGP table, right? So we have to configure its next hop address as 34.1.3 because we know very well that it will be reachable from, it will be accessible from R4. So now point is that in BGP you can update next hop address by using route map. So now I'm gonna do that actually. Like I'll create route map. Route map is name is next underscore hop. Permit by default 10 is there, right? I'm not going to match anything. If I wanted, let's say that I want to change next hop only for this specific prefix only, then definitely I will create one ACL. In that ACL I will call this prefix only, and then finally I'll call that ACL over here under this route map. Are you getting my point or not? But this time, because I don't have that specification, that I just want to change it only for 11111, because if I'm receiving multiple prefixes coming from R3, then also its next hop address for all prefixes must be 34.1.1.3. So I'll be doing it for all prefixes coming from R3. If R4 is receiving any prefix coming from R3, then its next hop address must be configured as 34.1.3. That is why here I'm not going to use match command, because if I do not configure any match command, then by default it will be match all. If you do not match anything inside your route map, by default it is match all. So this is match all, and then you can say simply set IP next hop is what? 34.1.3. So here you have set this next hop address as 34.1.3. Any problem? Tell me. So this is here you have configured this next hop address. Now just come outside, and now router BGP, move back into router BGP to router BGP mode, and inside router mode now you can apply this route map for this particular neighbor. So my neighbor was 34.1.3. route map name is just copy and paste it, and then in which direction these updates are incoming or outgoing? Incoming updates, because R4 is receiving this prefix coming from R3. R4 is receiving this prefix coming from R3. So for R4 this update will be incoming update. That is why I'm applying this route map for incoming updates only. Of course we can apply it on R3 as well, but in outbound direction, right? So I will be doing it in both directions, don't worry about that. But this time I have applied it on R4. Now you see show IP BGP. So still your changes have not taken place. So in BGP your changes will not take place automatically. So you have to say clear IP BGP star. Now if you say clear IP BGP star, then it will be hard reset, and the meaning of this hard reset is what? That it will break neighborship and reestablish the neighborship, right? So do one thing. Now I'm gonna to capture it. See the link in between R3 and R4, and then I will say I will configure this command on R4 itself actually. Oh sorry. So this is hard reset. In it actually neighborship went down and then reestablished, right? So IP BGP, you see changes have taken place. But in place of this command you could also use this command as well, clear IP BGP star in. The meaning by clear IP BGP star in, the meaning by this command is that it will send a route refresh request to all neighbors. It will send route refresh request to all neighbors. So this time it will not break, it will not tear down its neighborship, Means it is not hard reset. It's with using this command. Actually, you are simply sending a message, route refresh message to your neighbors. That's what the meaning by route refresh capability, which is by default enabled in version 4. We saw that route refresh capability and IPv4 unicast address only. These two things were by default enabled in BGP version 4. So after running this command into BGP, what will happen that it will send a route refresh message to its neighbor. So whenever, if you are saying in, it means we are forcing our neighbors to retransmit updates towards me. But for all neighbors, not for a particular neighbor. If you want to do it for a particular neighbor, then do one thing, say clear IP BGP and then 34.1.3 and then in. This will be for particular neighbor. So the meaning of this command is like I'm asking to this particular neighbor to retransmit my updates, towards me. The meaning by star was, it means you are asking to all neighbors. So even I can show you over here. See, this is route refresh message, right, which is generated by R4. See, generated by 4 towards 3. Simple. And then after it have given an update packet, this 3 to 4. See, 3 to 4. Update will be having path attributes and an array. Under an array, see prefix, under path attributes all those attributes. Fine. I hope now you have came to know that how to modify next hop address of prefixes with using next hop self as well as route map. Now you do one thing, move back again on R4, router BGP 655, sorry, it is using 200 and then remove this keyword from here and also say no route map and then say show IP BGP. Still it have not changed its configuration, right? Clear IP BGP star show IP BGP. See, gone. It's not best now. And next hop is again configured as 23.1.2. Now you do one thing, move back again on R3 and create one route map over here. Let's say next and permit 10 match. Don't match anything because we want to configure this next hop for all prefixes which are going in the direction of neighbor R4. So I'll say I will not configure any match command over here. I will simply say set IP next hop, and next hop will be what? 34.1.3. Whenever you will configure set IP next hop 34.1.3, and because this is the local address, right, this is our address, so it will always give you this warning that this is our address. So are you okay? Are you okay? I mean, are you really comfortable to configure your own address as next hop address? So because I know very well that I'll be configuring it for outgoing direction, for outgoing update, I'll configure this route map for outgoing update. So I know very well that there will not be any problem, but just try to think in perspective of a router. In most of the cases, you will always configure your route maps in inbound direction only. And in inbound direction, if you are configuring next hop as your own address, then definitely it can cause a big problem. That is why it will always give you this warning if you are going to configure your own address as a next hop address. Now, just come outside and then do one thing, router BGP 200 and neighbor is 34.1.4 and route map name is what? Next, in which direction? Out. Now still there will not be any effect on R4, see, but if you say clear IP BGP star in, and if you want to configure this command on R3, then you have to configure this command clear IP BGP star out. This command, this command instructs this router itself to retransmit all outgoing updates. So this R3 will retransmit its updates in the direction of R4, and you see this time again its next hop address has been modified. Tell me, is there any problem in next hop modification in BGP? If you are having any issue in modifying next hop addresses in BGP, please let me know or discuss it with me.
आउट लगाते हैं आपका अगर प्रॉब्लम हो सकती है क्या प्रॉब्लम
Can you configure your own address in outbound? I mean, in inbound direction.
नहीं इनबाउंड नहीं आउट
आउट में क्या प्रॉब्लम होगी? उसी में तो कॉन्फ़िगर किया है, प्रॉब्लम थोड़ी ना होगी, इसमें तो सॉल्व किया है. Hello, have you people understood this concept or not? Like you can also configure your route map in outbound direction as well, but make sure that it will be your own address, right? So whenever you will configure your own address as next stop address, then it will always give you that warning message that you are configuring on address as a next stop address. That's it. Fine. In this way we can perform it. We can do this. Okay. Now this R4 is not going to advertise it towards R5. Even you can move on R5. We can configure BGP. Remote AS will be neighborship have came up now. So IPBGP it is best for R4. You do one thing, move again back on. Nothing. Because R4 will receive it from IBGP neighbor, is not going to advertise it towards another IBGP neighbor, because R4 is not working as a route reflector. So in this way, in this case, if you want to solve this problem, you do one thing, move back again on R4 as well. On R4, say router BGP 200 and then say neighbor 34.1.3 is what route reflector. That's it. And this time you have configured this R4 once again as a route reflector, and now this R3 is configured as a client, and this R5 will remain as non-client. But you know very well that route reflector can reflect routes in between client and non-client. That is why this prefix will be available on R5. So remember that a single router can be client for one one router can work as both client as well as route reflector. See, this R4 and R3, both of them are working as client as well as route reflectors. I'll let you know these things in more and more details during route reflectors actually. There is a separate topic of route reflectors. So during route reflectors only I will teach you that, okay, how does it really work and all these things. Fine. So finally now you can move on R5, and on R5 also you can see that, okay, this is coming, but again it is not best because next hop is not reachable, because next hop will be I think 34.1.3, which is not of course it is 34.1.3, which is not reachable from R5. To solve this problem now, what can you do here? Either advertise 34.1.0 in like you can run any IGP over there, any IGP like EICRP or OSPF. You can advertise those prefixes into EICRP or OSPF so that it will be reachable. It will become reachable from all others. Are you getting my point or not? So you can use any IGP over here to solve this problem, or once again configure your route map. On R5 configure its next hop address as 45.1.4 so that it will become reachable from R5. Fine. So do one thing, once again create one route map, Cisco, set IP next hop as 45.1.4, router BGP 200, neighbor 45.1.4, route map name is what? In which direction? Because these prefixes are incoming prefixes for R5. Now see one thing, do clear IP BGP star, do show IP BGP, check it out, it's best now. Fine. Now do one thing, let's advertise something from R4 into BGP now. Network mask is, so now it will advertise it towards R3 at least. R3 is working as route reflector, it will give it to R2 now. Move on R2, show IP BGP, check it out. This 444 is not best, and if it is not best for R2, it means it will not advertise in the direction of R1. Check it out, is it there? Because in BGP only and only best route information can be propagated towards the neighbors. I mean BGP can propagate only and only best path information. That's why we are calling it as a distance vector routing protocol as well. So how can we solve this problem now on R2 so that it will become best on R2, and then R2 will start to advertise it in the direction of R1. So how can we solve this problem now? Do one thing, try to advertise this 34's network from R3 into BGP table. Do one thing, move on R3, router BGP is 200, then say network 34.1.0, mask is, so that it will become reachable from R2 now. This 34's prefix, right? Move back again on R2, show IP BGP, check it out. See, now 34 is there, and because 34 is there, it means it will come to know that how to reach this next hop. You understand or not? See, to reach 34's network, next hop address is what? 23.1.3, which is directly connected to R2. That is why both of them, 34's network as well as 4444, have become best. And now it will also advertise it. See, till here, to reach 4444, its next hop address was 34.1.4, but whenever R2 will give it to R1, R1 is eBGP neighbor. See, it will advertise it after modifying its next hop address automatically. Check it out. So it has proved that whenever BGP will advertise any prefix towards eBGP neighbor, it will always advertise that information after updating its next hop address. But in case of BGP neighbor, it will never update its next hop information, next hop address. Have you understood it or not? Tell me. So in this way, let me show you that the minimum time interval in between two update packets for eBGP neighbor is 30 seconds. So you see, interface loopback 1 is what? Shut down. Immediately it will be removed from R2. See, but if it comes up once again, so this time you will see that it will not come here immediately. No, nothing. No, but after all it will come, but after yes, 30 seconds only. That's why we say that BGP has slow convergence. Now if you go back to R1 and you shut down it, you will see that immediately it will be removed from everywhere. But once again, if it comes up immediately, then again it will take at least 30 seconds. Fine. Apart from it, fine. Again, I'm going to form. First of all, now I'll teach you rule of IBGP synchronization. There is a rule in BGP which is known as IBGP synchronization. So let's discuss that IBGP synchronization rule first now. Right? IBGP synchronization rule. See, nowadays this synchronization rule of BGP, nowadays this IBGP synchronization rule is disabled. By default it is disabled, as you can see here. Like you do one thing, move back again on our file, say show run pipe section router BGP. You will see that there will be a command no synchronization. Remember, this synchronization rule works only for IBGP neighbors, not for eBGP. Or you can say this synchronization rules works only for internal prefixes, not for external prefixes. Things are same, because if you are talking about IBGP neighbors, means you will be receiving internal prefixes from there, and if you are talking about eBGP neighbor, means that you will be receiving external prefixes from your neighbors. Is not it? Fine. So nowadays in BGP, in this BGP version 4, by default this synchronization is disabled, but they can enable it as well. Before enabling it, you must understand that what is the meaning by synchronization rule. See, or what is the meaning by IBGP synchronization, because technically I will be calling it as IBGP synchronization rule. See, according to the rule of IBGP synchronization, if BGP is learning any internal prefix, if BGP is receiving any prefix from its IBGP neighbor, it will never make it best. It will never make it best unless it starts to receive the same prefix via IGP. And here the meaning by IGP is what? ESERP, OSPF or RIP or whatever it is. It means that if you enable synchronization rule in BGP, then within an AS, for IBGP, like for an example, you have configured IBGP, but it will also be mandatory to configure IGPs along with IBGP. It will be mandatory. Like for an example, now I'm on R5 and by default synchronization rule is what? Disabled. See, show IPBGP, check it out. It is best. All of them are best. No problem at all. Everything is fine. Next hop is reachable, everything. Now what I did, router BGP 200, and then I said synchronization. This time I have enabled the synchronization rule in this BGP over here. Fine. And you see, remember the rule, this synchronization, if you change this synchronization rule for your BGP, then you have to perform hard reset. Otherwise your changes will not take place. You see, still they are best. Say clear IPBGP star. If you say in, then also there will not be any effect. See, you have to say, you have to perform hard reset. So it will break neighborship with all neighbors. Re-establish it. Show IPBGP. Are they best now? Now they will not be best. So according to the synchronization rule, whatever you have learned via IBGP neighbor, you must learn the same prefixes with using IGPs as well. So now it will be mandatory to configure IGPs over here. It will be mandatory to configure to run either OSPF or ESERP or RIP, RIP over here. Now that's fine, that we know very well that what is the effect of synchronization rule. But why BGP, I mean why this rule was developed for IBGP neighbors. Why this rule came into the BGP for IBGP neighbors? Tell me.
IBGP measure
Not loop prevention. Say
Black hole.
to remove black holes actually. To remove or to prevent your I mean in transit AS to prevent your transit AS from black holes. To prevent your transit AS from black holes. How? And remember, nowadays we are not using this rule. You know why? Because nowadays we are using MPLS, and MPLS have configured BGP free backbone. Means in backbone you will never configure BGP. But in MPLS there will not be any black hole because data will be forwarded based on MPLS. But previously when MPLS didn't came into the market, when MPLS was not present into the market at that moment, it was required to have this rule, synchronization rule. But only for transit AS, only for transit AS. So in all transit AS it was required to enable this rule of BGP, this IBGP synchronization rule. It was mandatory. Otherwise, see what can happen in your network. Just try to understand. I will draw a diagram, right, and I will try to explain you with using that diagram only. MS Paint. See, let's say this is customer site A is giving this prefix to R1, R2, R3, R4, and then R3 is connected with customer B, and this is AS1 AS actually, AS100, and this is what? ISP. So customer A is connected with ISP, customer B is also connected with an ISP. Fine, this is 1 AS, right? So you decided, what you decided over here, actually you configured AS100 and then you also configured OSPF here among all routers, OSPF 1 area 0. And then you configured a loopback on R1, you advertise it into the OSPF. You also configured one loopback, another loopback, you advertise it into the OSPF. And then you configured IBGP peering in direct neighborship with using their loopback address in between R1 and R3 only. IBGP neighborship. You understand? With using their loopbacks. Now you configured EBGP neighborship between customer A and R1, and also you configured EBGP neighborship with in between R3 and customer B, and this R3 is placed at the end of ISP. Now there is a prefix behind A which is 10.1.1.0/24, and there is a prefix behind B as well which is 20.1.1.0/24, right? They are I mean these are their lane networks, lane prefixes. Now definitely this R1 will advertise this prefix towards its EBGP neighbor R1. Now R1 is having another IBGP neighbor which is R3, so R1 will give it to R3 and then R3 will give it to customer B. So finally customer B will learn prefix coming from customer A, and in same manner customer B will advertise its 20's prefix to R3. R3 was EBGP neighbor for customer B, and then R3 will advertise it towards R1, and then further R1 will advertise it towards customer A. It means these two customers A and B will access their prefix with each other. But will it be really possible for them to communicate with each other over here? Just wait for a moment. Just try to think about it. So this AS100 is working as transit AS for these two customers, right? So will it be really possible for the lane users of customer A and B to communicate with each other? You know why? What will happen over here? If customer A is transmitting data towards 20's prefix, so customer A learnt it from R1, will send the traffic towards R1. R1 learnt it from R3, but still traffic has to go via either R2 or R4. Once traffic packet will reach either R2 or R3, R2 or R4, they will drop it. Because R2 and R4 do not have these prefixes available inside their routing table. So this is what black hole in transit AS. But in case if you are advertising BGP synchronization rule over here, if you are using BGP synchronization, of course for R3 R1 is what? IBGP neighbor. So R3 will not make this tens prefix as best prefix which was received from R1 until unless it starts to receive it via IGP. IBGP synchronization rule, if you have enabled it over here. So of course for R3, R1 is what? IBGP neighbor. R3 is receiving this tens prefix, right? See, this tens prefix is coming on R1, then R1 is giving it to R3. R3 is receiving it from its IBGP neighbor. Now if synchronization rule is enabled on R3, then the same prefix must also receive via IGP. And if it is not receiving same prefix with using IGP, which is OSPF this time, it will not make it best. And if it does not make it best, how will it be possible for R3 to advertise it towards customer B? Are you getting my point or not? In same manner, if 20's prefix is advertised from B customer B to R3, R3 will give it back to R1. Now R1 will receive this 20's prefix coming from IBGP neighbor R3, but R1 will not make it best until unless it starts to receive the same prefix with the help of IGP. I mean 20's prefix must also receive via OSPF as well. Otherwise it will not make it best. And if R1 do not make this prefix 20's, I mean 20.1.0/24 as best prefix, then it will not advertise it towards customer A. So if you have enabled synchronization on R1 and R3, this time customer A and B will not be able to exchange prefixes with each other, right? So now because synchronization rule is there, so you know very well that what should happen over here, right? So you have to redistribute BGP into OSPF, so that now R3 will receive this 10's prefix from R1. R3 is receiving 10's prefix coming from R1, and also it will start to receive that same prefix with the help of OSPF as well. Now that this for R3, that 10's prefix will become best prefix, and then this R3 can further advertise it in the direction of. But this time because R3 have also started it to receive via OSPF, it means this time this 10's prefix will be present on R2 as well as R4, because now it have started to receive it via OSPF. It means it is giving now guarantee, because if it is available in the routing table of the IGPs, it means it will be available on all routers as well. Try to understand. If R3 have started to receive this 10's prefix coming from R2 and R4 via OSPF with using OSPF, it means it is also available on R2 and R4 as well. So there will not be any black hole now. So now it will become best for R3, and then further R3 can advertise it in the direction of customer B. In same manner 20's will be followed. I mean 20's prefix will be followed. Are you getting my point or not? So according to the BGP, I mean IBGP synchronization rule, if you are receiving anything from one of the IBGP neighbor, then you must receive the same prefix with the help of IGPs as well. Like this one. What will I do? I will move on R5. I will say router BGP 200. I'll say no synchronization, and then I'll say wait, just for a moment, right? I will show you that it will become best for R5 now. Show IP BGP. It have came up. See, all of them are best. Fine. Now R3 is getting this prefix. I mean once the prefix of 1111111. R3 is getting prefix 11111 coming from IBGP neighbor R2. Now you do one thing, move back on R3, and on R3 you do one thing, do show IP BGP. See, this is best now, right? This is best for 11111. Now say router BGP 200, and then say synchronization, and then say clear IP BGP start, and then you will see that for this 11111 will not be best for R3. And if it is not best for R3, see 111 is not best. And if it is not best for R3, this 111, how will it be possible for R3 to advertise it towards R4? And how will it be possible for R4 to advertise it towards R5? So you move on R4 now, show IP BGP. You will not get that 111 over here. And also you will not get this 111 available on R5 as well. Oh my god. I mean, of course you will not get this 1111 on R5 as well. So that's the problem now. How can you solve it now? By implementing IGPs. like you can implement here, like in between R2 and R3 I can enable EIGRP router EIGRP 100 not assembly network 23.1.2, and in same manner I will move on R3. I will say router EIGRP 100 not assembly 23.1.3. neighborship will come up, EIGRP neighborship between R2 and R3, but still I have not redistributed BGP into EIGRP onto R2. That is why here, if you see show IP route EIGRP, is it there? Is it receiving anything over here? Show IP BGP, have it defined best this 1111? Not now, right? So move back again on R2 and do one thing. Say router EIGRP 100 and then say redistribute BGP 200 matrix 154401 02451 and 1500. Fine. Now move back again on R3, show IP route EIGRP. Check it out. It have started to receive. Tell me. It have started to receive this 111 via EIGRP. However, in its routing table, it will install this route via EIGRP. But now, if you check its BGP table, it will become best. However, it will show you RIP failure, but at least it will become best. So if it has become best, and also this R3 is having this prefix available inside its own routing table, so it will start to advertise it in the direction of R4 as well. See, via BGP. So it will happen over here. So if R3 is receiving anything from R1, the same prefix information must also receive via OSPF. If R1 is receiving anything from R3, then R1 must receive same information with the help of OSPF as well. Otherwise, it will not make it best. This is called synchronization rule. But nowadays it is no more in use. Nowadays it is not longer in use actually. We are not using it anywhere because nowadays we are using MPLS. You will be using BGP only on edge routers. On core routers you will never require to enable BGP. But still those core routers can switch your data based on MPLS. There will not be any black hole. So previously when we were not having MPLS, then in that case, in that situation, this rule was really important and it was by default enabled at that moment. Now it is by default disabled because nowadays it is not required to enable synchronization anymore. Of course, and otherwise how will it be possible for R2 and R4 to switch your data if they do not have route available inside their routing table? Do one thing, either enable BGP on all devices in fully meshed or perform redistribution. But in case if you are having fully IBGP neighborship, then also, and in case synchronization is still enabled, then again you will require to perform redistribution along with fully meshed IBGP peering as well. Because rule says that if you are receiving anything from your IBGP neighbor, it will not make it best unless it receives the same prefix via any other IGP. So I hope that you people have understood the uses of synchronization. Fine, very good. Now, once again I'll configure indirect neighborship. Indirect neighborship in between R1 and R5 itself. Indirect neighborship. So again I will require to configure any ICP between them so that they can form IBGP neighborship, right? Indirect neighborship, fine. Because if they do not have reachability with each other, how will it be possible for BGP to form peering? Hey, if you are going to form indirect neighborship in BGP, whether it is IBGP neighborship or EBGP neighborship, then at least those neighbors must be reachable to each other. If they are not reachable to each other, then definitely it will not be possible for you guys to form neighborship. Fine. No router BGP 100, comma, to no router BGP, and also no router EICRP 100. In same manner, move on R3, no router EICRP 100, no router BGP 200. And R5 also. Fine. I wanted to configure IBGP peering in between R1 and R5 this time. So I have to configure any ICP between them. So let me configure EICRP router EICRP 100 node of somebody network, and then so EICRP will get enabled onto these interfaces. See, same manner on R2, router EICRP 100 node of somebody network. Ping. Fine, no problem related to reachability now. Now I'm going to configure IBGP neighborship in between R1 and R5. So I'm on R1. Let's say we have configured router BGP 100. Sorry. Neighbor is what? Remote AS will be, and then 4.5.5.5 update source will be loopback. Move on R5. Neighbor, remote AS will be, and then update source will be. Fine. Neighborship will come up now. Neighborship will come up. See. Now I'm having one loopback over here with 50s network. I will advertise it into the BGP table. Router BGP 100 network 50.1.0 mask will be /24. Fine, it will be advertised into the BGP table. Finally, it will give it to R1. On R1 also I will create one another loopback 10 IP address 10.1.1, and finally I will advertise it into the BGP network 10.1.0. Mask value will be, see, first of all let it receive all information from its neighbor. See, 50s prefix is here, 10s prefix is directly connected to R1, then it will give this 10s prefix to R5, and 50s prefix is directly connected to R5. Fine. Now as you can see here on R1, show IP route, that it is having 50s prefix available inside its own routing table, and you must see that. Where is that? AD value is what? 200. And now on R5 you must have this 10s prefix available inside its own routing table. So I hope that you have seen that. This is, and next hop is what? 1111, is not it? Because we are getting it from neighbor 1111 only. So now you can try to communicate with 10.1.1 when source is your loopback 50, because 50's network is directly connected to loopback 10, sorry, loopback 10 on R5 itself, right? So are they communicating with each other? No. You know why? Whenever it will reach R4, it will drop it. And this time you are getting request timeout. You know why? Because R4 do not know that how to send unreachable message back to 50.1.1.1, because R4 doesn't know even about 50's network as well. But if you try to ping your 10.1.1 without specifying your source, then you will see that R4 will be having returning path, so you will get U. But this 50's prefix is also not available on R4. Previously in source I was taking 50's prefix, 50's network. So even R4 was not having that how to send unreachable message back to 50's network. Have you understood it? So still there is a black hole, big black hole. So they are exchanging their prefix with each other, but still they cannot communicate with each other. To solve this problem now, we can use GRE tunnel. To solve this problem, again we can use here GRE tunnel. And you can use GRE tunnel whether your neighbors are IBGP neighbors or eBGP neighbor, doesn't matter. So this time I'm going to use here GRE tunnel. So what will I do? I will move on R1, because I know from R1's FA0/0, even from the loopback of R1 I can reach the loopback of R5. So I can configure tunnel in between R1 and R5. So what will I do? I'll create one tunnel interface here. I will allocate an IP address from 192.168.1.0 range. Fine, and tunnel source will be my own loopback 1, and tunnel destination will be, and then move on R5. Interface tunnel 1 IP address 192.168.1.2. Tunnel source was, and tunnel destination was, ping 192.168.1.1. Of course, from tunnel to tunnel you can communicate with very easily without any problem. You understand what I mean to say here? See what will happen actually if you move on R1 and if you check that 192.168.1.0 is directly connected to tunnel interface, and you know very well that whenever any packet will go through the tunnel, another extra GRE as well as external IP header will be added onto it. And in that it will be having source as 1.1.1.1 from here and destination as 5.5.5. So of course R2 have that information that how to reach 5.5.5 and how to reach 1.1.1.1 as well. R2, R3 and R4, all of them. That is why it is possible to reach from R1 to R5 with using tunnel. Now what can you do actually? Show IPBGP, check it out. To reach 50's network, right now its next hop address is what? 5.5.5. Do one thing, use route map or whatever you want to use, but configure its next hop address as the tunnel address of R5. Configure its next hop address as the tunnel address of R5. So whenever this router will send any traffic towards 50's network, it will send the traffic via tunnel interface, and then you know very well that what can happen. What will happen? Try to understand.
Able to reach the
Because we can easily communicate via tunnel interfaces, right? So here you do one thing, to reach 50's prefix from R1, modify its next hop address and configure its next hop address as the tunnel interface of R5. So now do it on R1. Configure one route map, next underscore hop, commit 10. Don't match anything because you will apply it for all, and then say set IP next hop is what? Tunnel interface address of R5. And then do one thing, router BGP is 100, neighbor is 5.5.5, say route map, name is in which direction? Do clear IP BGP star. Now check is BGP table. In same manner, move back on R5. Do show IP BGP. To reach 10's prefix, its next hop address is 111. Make it tunnel address of R1.
सर एक बार R1 से पिंग करना.
Wait.
एक बार please.
What?
R1 will be
So what will happen?
with the integer.
Returning path will not be there. Packet will come here, but return path is not available over here. Even R5 will give it to R4, but R4 will drop it. Reverse packet will be dropped. You can come from R1 to R5 now, but R5 will give it back to R4, but R4 will drop it here. So now create one another route map over here. Let's say Cisco or CCIE permit 10 match, don't match anything, say set IP next hop as the tunnel address of R1, and then router BGP is what 100, say neighbor 1.1.1, say route map CCIE in which direction. So do clear IP BGP star in do show IP BGP, check it out to reach 10 prefix, and now ping 10.1.1 when source is loopback 10. And it can be done in case of both, like IBGP as well as EBGP. Finally, you have to modify your next hop addresses. Finally, you are taking your traffic via tunnel. So these types of black holes can be covered with the help of GRE tunnel. You could also do one another thing over here, like configure tunnel interface, remove BGP, configure tunnel, and then configure BGP peering with using their tunnel interfaces itself. Then you will not require to configure these route maps and all. Are you getting my point or not?
Yes.
Apart from using these route maps to modify your next hop address, what can you do? Configure tunnel interfaces first and then configure BGP peering with using tunnel addresses itself. So their next hop will be tunnel addresses only by default. Have you understood it or not? So on R5, do show run pipe section router BGP. This is your configuration now. You just applied route map. You just configured route map only. Understood? So this is that how can we use GRE tunnel, or how can we implement BGP over GRE tunnel. So I hope that you people have understood it. And also you can configure BGP peering over tunnel interfaces as well. So even you can move back again on R1, ping 50.1.1.1, and source is its loopback, repeat. Performance is slow because encapsulation and decapsulation is done by devices. Addresses as well. I have recorded this diagram into video now, so draw it and try to memorize its IP addresses as well. Okay, one more thing in between. See, inside the internal network of this customer, OSPF1 area 0 is configured, and IP addresses are something like that. That in between R1 and R3 we are using 192.168.13.0/24, like 192.168.13.1 on R1, 13.3 on R3. Then in between R1 and R4, 192.168.14.1 at R1, 14.4 on R4. In between R1 and R2, it will be, it's recording, 12.1 and 12.2. In between R2 and R4, it will be 192.168.24.2 and 24.4. In between R5 and R6, 192.168.1.56.5 and 56.6. In between R4 and R6, 192.168.46.4 and 46.6 at the end of R6. And also they are having one loopback interface, loopback 0. 150.1.1 on R1, 150.1.2.1 on R2, 150.1.3.1 on R3, 150.1.4.1 on R4, 150.1.5.1 on R5, 150.1.6.1 on R6, and they are reachable with each other with using their loopback addresses. OSPF is configured over there, and then accordingly we can configure BGP here. Of course, BGP will be required. It will be required for us to configure BGP at least on R5 and R6 because these are edge routers. And for customer, we are using BGP AS65500, whereas Sprint is using AS21545, and BT will be using AS35500, whereas New York router will be using AS8127. WAN IP addresses are public addresses. They are already configured. You can see them. That's it.